Hello, I'm Sid. Today we'll be learning about memoization in JavaScript. Sometimes we deal with pure functions. What happens is that every time we pass in the same input, we will be receiving the same output. For example, when we have to find the square of 2, we will be receiving 4 as the output. Similarly, if we have to find the square of 3, we will be receiving 9 as the output. Also, we deal with functions that take high computational time. When we are sure that every time we will be passing in the same input, we will be receiving the same output, then what we can do is we can cache the output for that specific input. So what will happen is that whenever we will be calling that input multiple times, then we won't be calling that function all over again and do the complex computation. Instead of that, we will be simply returning the output from that cache. So we will be looking into this example. Over here you can see I have already written this factorial function, and over here we will be logging in the result, and we will try to find out the computation time for this function. So over here we will be using the time function, and in this let's pass in no memo value, and right after the function call we will be calling time end function. Now we will be executing this program. We can see the output of the factorial over here, and we can see the computation time, that is 3.28 milliseconds. We will try to reduce this computation time with the help of memoization. So over here we will be declaring one memoization function. In this memoize function we will be taking a callback function. We will initialize a cache over here. I'll be explaining how we will be using this cache. We will be returning a closure over here, and in this we will be accepting arguments. So this is an anonymous function in which we will be accepting an array of arguments, and we are using a rest parameter over here. The reason is that we are unaware of the number of arguments a specific function might take. Therefore we will be using an array of arguments. Now we will try to find out this argument inside this cache. So what we will do is we will convert this array of arguments to string, and then we will try to find this argument inside this cache. What will happen is that this argument will be like a key inside this cache, and if we are able to find that key inside this cache, then we will be returning the corresponding value. So you can see over here that inside this cache we will be passing in the key that we have found, and we will be returning the value, and we won't be calling this callback function, and we won't be doing that computation all over again. And let's say that we are not able to find the key in this cache. That means we have not called the callback function with this specific argument for the first time. So what we will do is yes. So what we will do is we will be calling in this callback function, and in this callback function we will be passing in the arguments. Again, it will be in the format of rest parameters because we are unaware of the number of parameters that we have, and whatever output we get from this callback function will be getting saved inside the cache for this specific key, that is arguments to string. And in the end we will be simply returning the output that we got for that specific key. So what we will do is we will declare one memoized function for this factorial, and we will be calling this memoize function and passing in this factorial as the callback function. Now we will be calling this memoize factorial, we will be passing in the same value that we were passing previously in the factorial. So what will happen is that initially we called this memoize, and in this we have passed in this callback function, and we will be returning this specific closure over here, and this closure will be able to access this cache because it is inside its lexical scope. And now what we are doing is we are simply calling this memoize factorial, and this specific closure is being returned, and this specific argument was being passed over here. Now let's try to find the computational time. let's call it memo, and right after the function call, again we will be calling this time end function. Now let's try to run this program. Now you can see that now we have called this memoized function and the computation time was 0.189. So you can see that we have reduced the computation time over here, and the output that we got was also the same. So in this way we can optimize our function. Thank you for watching. Please like, share the video and subscribe to the channel.